Hello everybody, in this question on functions. The function f and g are defined by fx equals x squared minus 2 over x for x greater than equal to 2, and gx is x squared minus 1 over 2 for x greater than equal to 0. So we need to state the range of g. We are given that x is greater than or equal to 0. So for the part 1, if I were to put in x is 0, so g is 0, it would be 0 minus 1 over 2, that is minus half, which means the minimum value of g, it would be minus half. So I'm going to write here that g of x is greater than or equal to minus half. So that is the answer. So the next bit for the part 2, it's saying that explain why g of 1, f of g1 doesn't exist. So for the part 2, I can just write what g of 1 is, and that would be 0. And you see f of 0 does not exist. That's because it is x equals 0 here, so that's not possible. That's solution is not possible. So then f0 doesn't exist. So that's the answer. The next is for the part 3, we need to show that g of fx is equal to ax squared plus b plus c over x squared. So here, what is fx? And then that would be for the question 3, I can write g of fx is equal to g of x squared minus 2 over x, and that is equal to so we need to replace x with this x squared minus 2 over x. So I can write this as equal to, so that is equal to x squared, so x squared minus 2 over x whole square minus 1 over 2. So that is equal to should be, so that is x squared, so that is x squared minus 4x to the power 4, x to the power 4 minus 4x squared plus 4 over x squared minus 1 over 2. So that is x to the power 4 minus 4x squared plus 4 minus x squared over 2x squared. So then I get that as equal to 2x squared, and then x to the power 4 minus 5x squared plus 4. So then I can divide individually. X to the power 4 over 2x squared minus 5x squared over 2x squared plus 4 over 2x squared. And then I can cancel these, and the x's, and I will be left with half x squared minus 5 over 2 plus 2 over x squared. And you see, this is of the format, so this is g of fx, and this is of the format ax squared plus b plus c over x squared. So this is ax squared plus b plus c over x squared. It's in this format. So hence we can say a is half, b equals minus 5 over 2, and c is equal to 2. So that is part 3 done. next we need to state the domain of GF. So for the domain of GF, so what part is that for? So domain GF, so what happens is x cannot be 0. So we say x is not equal to 0. Okay, so then for the fifth part, this is saying show that f inverse of x. So let me write it down. So change the color. So we're saying f inverse of x is equal to x plus square root of x squared plus 8 over 2. And we are given fx is equal to x squared minus 2 over x. So we can approach this a bit differently, you know. I mean, start from the back, you know, start from the end, you should say. Start from the ends. If you start from here, if I say that f inverse of x is equal to y, right? So then I can say hence y is equal to x plus square root of x squared plus 8 over 2. So I can now say I will try to make x the subject of the formula. So then I will say try to make x the subject of the formula. So how do we do that? So we can say therefore 2y is equal to x plus square root of x squared plus 8. So hence 2y minus x. So I can square this. So I will end up with 4y squared minus 4xy plus x squared is equal to x squared plus 8. So the x squares go away. So we're trying to make x the subject of the formula, hence we get 4xy is equal to 4y squared minus 8. So then if we eliminate these 4's, we get xy is equal to, we are dividing by 4. So xy is equal to y squared minus 2. So you see we get x is y squared minus 2 over y. So what is this? That is equal to f of y. So if fx is this, then f of y is y squared minus 2 over y. And we got that is equal to f of y. So f of y is equal to x. So from here we get f of y is equal to x. And you see we have proved that f of y is equal to x. So hence we have shown that f inverse of x is equal to x plus square root of x squared plus 8 over 2. Okay, so that completes this question.